And for rounding, don't worry about rounding. I say generally just go to the third decimal place to round and you'll be safe. Just don't worry about it too much though. Wait, you gotta go? Okay. That's a lot of conversions. That's a lot of conversions. In fact, that covers metric conversions, that covers factor label conversions, it covers a lot of things. Good.
With each topic, you should make a new recording and lay it up.
Ooh, that's a good idea. But it also takes a lot of work to do that. I just want to put it up as quickly as I can. Let's see. We got classifying matter. Let's try that.
That's the one.
And it's also good just to go through everything anyway.
And then wait, what's the thing that's e to the 10? What's that thing called?
It's called scientific
Oh,
notation.
yeah.
Yeah. Okay. So let's do classifying matter, the vocabulary. This is kind of like, this is something that shouldn't keep you up at night. Crying in your pillow. You shouldn't be thinking too much about this vocabulary. Okay. What I did before is I just had this big flow chart, and that's what I want you guys to be focusing on is that flow chart. Yeah, it's just knowing what types of matter there are in the world and in the universe. So matter, which is anything that takes up space, and I'm just going to go through this really quickly. I'll just go and stop at every branch along here and talk about it. Matter is divided into two things, basically. Substances and mixtures. Substances and mixtures. Substances are things that cannot be physically separated. You can't physically separate them. And mixtures are things that can be physically separated. So physically separated, what do I mean by physically separated? I mean,
Like sand.
like sand is a good example. Yes, you can go in there with the tweezers and take out bits that are different from other bits.
Sand
Right.
is just crushed up rocks, right?
Yeah, it's like crushed up glass, really, silicon.
Ooh.
So
Yeah.
Why is that?
we have
But it's nice and
we
smooth.
have to give like examples of each thing.
You, let's say we give you an example, then you can identify it. These kinds of questions are usually in multiple choice formats. So it'll be like, just like in our workbook where it gives you
So it'll be like
this kind of
what-
fill in the blank. Like it says, a colloid is a blank that never settles. And that could be, and the correct answer is silence.
Heterogeneous.
We have heterogeneous mixture, right? It turns out, should I do? We want to fix this. It turns out to be homogeneous mixture. That's a slight change. I didn't go over the change in class. That's one little slight caveat. I do need to go over that with you guys. I'll do it tomorrow too. Okay, so that's a small change we need to change in the workbooks too. It'll make everybody panic, and right now you're panicking, but tomorrow you'll be like, oh yeah, this is what he said. So it's homogeneous mixture. It's actually a homogeneous mixture.
So colloids are homogeneous?
Yeah. We'll talk about that tomorrow too.
10 days, and I got changed everything.
Oh, I know. Substances can be broken down into two separate kinds of things. Substances can be broken down into elements and
Okay.
compounds. Compounds are just combinations of elements. That's a nice way to remember it. It's like one type of element, one type of atom. And compounds are two or more different types of atoms. So I just drew little circles to show that to myself. These things cannot be physically separated. So you can't go in there with tweezers and take apart an oxygen away from hydrogen in water. It'd be really tough to do that. You have to do it with chemistry or electricity. Do that too. But you can't be chemically separated, these things. They can't be chemically separated, or they can't be physically separated. Blah. They can't be physically separated. Can't be physically separated, can't be physically separated. These things are two or more substances that can be physically separated. Okay? So basically, this is the smallest unit you can get into anything that's a matter. So elements are the small stuff, right? If you put two different elements together in one thing that can't be separated, you've got a compound. All right? If you put maybe two different compounds together that can't be physically separated, then you've got a mixture. All right, now those mixtures can be broken up into two different types as well. We've got homogeneous and we've got heterogeneous. Homogeneous means things are uniform, they're the same. And heterogeneous means that things are different. They don't look the same when you go inside them and take a peek. Heterogeneous. Homogeneous. Homogeneous. Heterogeneous. Homogeneous are things like solutions, like salt water. Salt water. If you look up really close on salt water, you see these little sodium atoms next to water atoms. And you also see little chlorine atoms next to water atoms. But they're so small you can't see them. You look through them, you can take the saltwater challenge and you don't know which one's which. And you drink the salt water on accident and you go, oh, it's gross. But it looks the same as water. That's a solution. Another homogeneous solution could be, I don't know, Gatorade. That's something that's that you can't tell that there's little tiny things dissolved in it. Overall it's a different color, but you can't see that there's anything in it. Anything that you can't see, that there's obviously something dissolved in it, then it's a solution.
Like the clear paper vitamin water?
Yeah. Yeah.
One
Exactly.
are called heterogeneous.
Now, heterogeneous is a suspension.
Kind of like smoke.
Yes, that's like smoke. That's like when something is in. Actually, no. I'm sorry, I was thinking about something else. Suspensions, something like a smoothie or sand water that eventually settles down to the bottom. It's so big. The things that are dissolved in it, so big that it's a solution. Like snow would be an example of a suspension, I guess. If it snows like in the air, and eventually it'll come down and settle down into drifts.
Can you unmake a smoothie?
You could if you had really good filters.
Really?
Yeah.
So you can like make a banana back?
What?
It would take a lot of time, wouldn't it?
You can do that?
It'd be tough. All right. It'd be almost impossible to do.
Well, like a
Homogeneous. The other thing we're talking about is colloids, Alex. So this is one thing that you want to remember. A colloid is something like smoke, as you said, where you shine some light through it. You can see that there's little stuff in it, but it doesn't ever settle. It's uniform. Colloids, that's something like smoke, and that's something like fog. Okay? It's especially that's something like smoothie.
So about like fire.
Yeah.
I remember when the 9/11 happened. There was like fire that was just like chilling in the sky. How did that
Chilling.
happen? It was just like sitting there.
Right.
Like something was on fire. There was nothing there. It was just fire. Maybe it was like lost. Like, I have a vivid memory of just seeing on TV just fire, just like where the buildings were. And it was like fire. It was like fire. Is that possible?
Just fire in the air.
Yeah. Not touch anything.
Yeah, you can have just gas ignite.
Gas.
Like fire just sitting right here.
It wouldn't just be sitting here. Fire is all it is just a reaction happening. Somehow energy is being released so much that it's actually exciting all of the atoms around it that makes it give off light. Okay? That's all fire is.
So fire could stay there and like not touch anything, just stay in the air.
Yeah, but there'd be gas being shot up into it from below probably.
So it's definitely possible that happened, right?
It could be possible, yeah. What else? We should talk about. We did that. We did classify matter. Percent air. Let's do that real quickly, and then scientific notation. We'll call it a day.
Alright.
Okay, let's do it. So, percent air is probably one of the easiest things you can do. Let's say you get, like, let's say in your labs, for instance. Let's say that you got a density of, let's say you got a density of 2.81 grams per centimeter cubed, but that was your measurement. So you measured. That was a class average. How about that? A class average. And you think that this is aluminum. And aluminum's density is 2.70 grams per centimeter cubed. That's aluminum's density. That's the accepted value. They also call it the actual value.
Wait, that's the class average, and that's the accepted.
That's a class average. Class average. Measurement. And that was the accepted value. I'm going to put this in blue. The actual. Okay, that's going to be in blue. So, what you do is pretty simple. You take, in this case, we'll take it doesn't matter which one you multiply or which one you subtract from the other one to start off with, because it's going to be an absolute value anyway. So let's just take the easy one. Let's say that it's going to be 2.81 grams per centimeter cubed minus, I'm going to do this in blue, 2.70 grams per centimeter cubed Then take the absolute value of that divided by 2.71 or 2.70 grams per centimeter cubed. Now, what happens here is that the units eventually will all cancel out anyway, so you don't need to worry about the units too much. And then you take this number times 100. Whatever you get as an answer here, you take that times 100.
Wait, is it positive to actually negative?
Whoa. It cannot be negative. Why?
Because the absolute value, but it's not the absolute, but it's the absolute value before you divide it.
It's the absolute value of this one right here. So the difference between these two values. That's what you really care about.
So the absolute value, that's 11, 0.11. Yeah. Okay, but 0.11 divided by 2.70, wouldn't that be like a negative number?
No.
But what if you subtract, let's say, what if the number on the left is a 3, and the number on the right is a 2? So we gain 1. And 1 divided by that is a negative number then.
It's not mine.
It's not a negative number?
Prove it to yourself if you don't believe me. You just proved it to yourself. Okay. It's not going to be a negative number. It cannot be a negative number if this is positive and that's positive. No matter how small it is, doesn't matter. Okay? All right. So this is whatever percentage you guys get. I don't know if you tried this. 4.07. 4.07. Percent. Don't forget the percent. The percent is a unit that you need to remember to put in. Okay, that's it. Okay, that's it for a percent error kind of problem. Did we go over a really tough one for this, where we didn't know what the? I think we might have. We did once. We'll save that for tomorrow in class. But this is the easy one. Yeah, we had to replace this with an X. Remember that?
Yeah.
Oh, yeah.
It's not that much.
Yeah, we'll go over it tomorrow. Let's go over scientific notation now. Scientific notation goes like this. Scientific notation, I'll do it both ways. Because one way is pretty easy, the other ways might be a little bit more confusing. Let's do this. Alex, I need your help.
Yeah.
I don't know what this number is in scientific notation. And I don't know what this number is in scientific notation. And I don't know what this number is in regular notation, and I don't know what this number is in regular notation.
Well, the first one is 3.8917.
Good. Good.
Negative 4.
E.
Wait, sorry, E4.
E4. Why is it E4 and not E negative 4?
You're moving that way.
Because you're moving this decimal in this direction. Yes.
And the next one would be 5.2 E negative 7.
1, 2, 3, 4, 5, 6, 7. Yes, negative 7. Good. Very good. Now, what about this one?
This one is going to be 2, 1, 5. Wait, don't move it to, yeah.
That's it?
0.0. Wait, sorry. 1, 2, sorry, 0.0.
Yeah?
No.
Is that what this number says? No, it's not.
No, zero, that's on their side. 0.0.
0.0. So let's see what this, if we take a look at this number, these are the numbers that we're considering when we move decimal places, okay?
Yeah.
Okay, so we look at this number, and then you start moving decimal places, and you consider where this is telling you to move it. This is telling you to move it, negative, so we've got to move left.
Oh, yeah,
okay, so we're going to go 1, 2, 3, so it's going to be 0.00.
0.0. I said 0.0.
Yes, I know what you said. It's on tape. Okay. So you're gonna start with this. And this is what you're considering when you're talking about moving decimals.
I have the next one.
Next one, where's it gonna go?
Next one is going to be 3, 9, 9, 0, 0,
Oh my God.
0, 0, 0, point.
That's it.
Point 0.